Good afternoon. Welcome to the second Enterprise Innovation broadcast. If you hopefully you might have been able to see the first, and we have the same guest speakers back here, Thomas Hudak and Randy Olinger. Both are top engineers and architects at a very large enterprise firm that will remain unnamed. I've worked with them for quite a few years, and they bring a lot of experience on how to build operational excellence, how to innovate, how to bring new technologies into these big enterprises, which can be dinosaur-like and turtle and slow-moving, et cetera. So the question is, how do you make big changes at big places? Because that can have a lot of impact. So that's our general kind of theme and topic. So welcome, Tom and Randy. And this week we've got three sort of separate topics. The first two are Kafka, just in general, how folks are using Kafka, what directions we're seeing there with event messaging and streaming, and how that's affecting data architectures at enterprises. And then we'll talk a bit about Colonial and SolarWinds, some of these latest big hacks and where security is going. And if we have time, we'll talk a little bit about Linux infrastructure and file systems, something that three of us have worked on in the past. So with that, so maybe to get started, Kafka's become very, very popular. It's clearly one of the most popular open source projects out there. My company, Oracle, makes sure that its products integrate well with Kafka because a lot of our customers are using it. So maybe the first question to each of you is just, what's the big deal? Why is Kafka become so popular across large enterprises? What big problem is it solving?
Well,
Randy, you want to take a crack at that?
Yeah, I can. I'll try to abstract it a little bit. The big problem is how to take your legacy applications that were never really meant to support online usage, meaning direct access to customers via this wacky weird thing we call the internet, and expose that data. So for years, people tried to do that. You had multiple connection technologies going all the way back to Corba or even RPC before that. You could write a little piece of code that would hook you up to the database of your order management system and put your website on it. And then you have a sale and 10,000 people come to your website and take your order system down. Those types of things are bad. And so people started writing scripts to copy data and to replicate data in their own ways. And you know how scripts are. They run sometimes, most of the time, and then they get the data and it's got some latency. Maybe it's 10 days old or 10 minutes old. You don't really know.
Yeah.
So that causes other types of operational problems. And then somebody, I don't remember who wrote Kafka. It might have been LinkedIn or Facebook or one of the large tech firms. They said, we're going to solve this by essentially building a better queuing system. So there's been MQ services for a lot of years to kind of solve the same problem, but they built a more open and generic queuing system that is really what they call a streaming system. And the idea is you make it incumbent on your system of record, your system of truth, which would be like your order management system or your ERP or something like that. When it gets updates, it pushes an update to the stream. So, Randy updates his phone number, boom, within a millisecond, that is pushed onto the stream. And anybody that wants to know about Randy's phone number can subscribe to that stream and they can get it now or whenever they need it. And then you can put automation in the stream to push changes out to things and replicate data and build up these things they like to call systems of engagement. These are kind of industry buzzwords from a few years ago, but the system of engagement was supposedly the data system to support your scalable web architecture or your customer management systems or your reporting systems or anything you wanted to decouple from your online transactional systems. So it provides a layer of protection and a layer of abstraction. The other thing, if you're a company as large as ours, you typically have more than one of each type of system. So, how many HR systems do we have? How many payroll systems? How many customer management systems? That kind of thing. It allows you to use those systems. The Kafka system can get feeds from all of them as long as they subscribe to a common data format or a data model and publish that into systems of engagement. And then you can host those system engagement on whatever data structure you'd like, whatever database system you'd like, whatever middleware, whatever API, web serving, whatever. So I think of it as a way to decouple information and a way to abstract and integrate information.
Very cool. Tom, your thoughts?
Yeah, I mean, it's taking the idea of MQ and sort of advancing it with some architectural changes that make it a little bit more scalable and less synchronous, right? We're getting away from, ACID database type transactional workloads that don't require that sort of, sturdy rigidity and reads and writes, right? So you can just shove a bunch of data in as you get it into a topic, and things can pull it as they need it when they need it. So yeah, very much the decoupling of sort of those old rigid approaches to transactional databases where your actual query data wasn't particularly transactional, right? Simplifies a lot of that stuff. I think what a lot of people end up doing though is they don't understand how to use it, or they're not coming from a message queuing platform or background, and so they treat it like it's a database, right? You use it to just load in a raw data set, and then try and publish a bunch of changes through various topic configurations and a bunch of custom code, and really it's much more efficient for just receiving thinking of it like a stream of events, right? And those events can be any kind of structured or unstructured message data. As long as you support that structure, then you can pull from it as you need it. Makes it a lot friendlier for a non-OLTP type workloads, for web applications especially.
Right.
I agree. The misuse of it is a great point. People to treat it as a database. There are things that you can, like Redis is a good example of a kind of in-memory scalable database type system. You can shove data in it, you can query data out of it, you replicate it on a bunch of nodes, and it's all in RAM and it's wicked fast. So use the right tool for the right job.
Yeah.
And Redis is not a streaming platform.
Right.
Kafka
and it's not a database really.
No, it's not. It's a data
Yeah.
store. It's more a database, maybe in the more generic sense of a database, but you're not going to run SQL against Redis. It's a key value store.
Yeah.
So I have so my question is that this all makes a lot of sense, but so when you're in a very large enterprise as you guys are, and you go to Kafka, the sort of messaging architecture, I can see all the benefits, but then you've kind of there is who's in charge of having maybe a global view of what's going on with data at all these various Kafka endpoints, and is there how does the enterprise figure out its goodness, because it's sort of like it's almost like from below. Individually, you can set up. I can connect to a particular stream. I can inject into it, and people can subscribe to it. But organizationally, how does that play out? And is that working? Where are you guys seeing progress in being able to kind of innovate around this new approach?
You go, Tom.
Well, it's definitely changing the way people are approaching how to use it as a tool, right? There's a couple different internal, programs around Kafka. The Kafka as a service is one that sort of is trying to provide a very opinionated approach to Kafka. So they limit topic sizes, they limit message sizes, they limit the types of activities you can do, with the purpose of trying to push you towards the best practices for how the system is designed to function, right? But then there's always a learning component to it, right? I mean, if you don't actually follow up with the groups that are the developers and the backend architects that are pushing new use cases for Kafka, then you tend to fall behind in terms of how you use it. So you still have to be up to speed on what people are doing with it in the open source and broader community. What's always tricky about very powerful platforms is they can be very complicated, right? And so you don't want to put too many rigid rules around it. There are best practices for things like performance, but and architectural design. But if you start limiting the way that it functions internally, then you limit the creativity of the way that people can create new things for it.
Right. Absolutely.
Yeah.
Yeah, that total that constant conflict or tension between standardization and letting people kind of bubble up innovation from below.
Mm-hmm.
I think we have two levels of use of it too, if not more, but I'll describe just two. One is I'm an application team and I've got some use cases for streaming in my application between my different components. But like I described earlier, I want to have a reporting system and I want to have a transactional system, and I'll connect them up using Kafka and maybe some change data capture that funnels over Kafka, something like that, some streaming use case.
Yeah.
And our architecturally, our opinion on that is it lives inside your application. Go crazy, good for you. If you screw it up, it's your problem. Run it the way you want to run it. And then we've got this other type of thing where we're talking about gluing together organizational assets. If we think about our organizational data, all of the data in the entire organization that's under the same stock ticker symbol, we say, well, that's kind of important and that's kind of precious to the group, not to the individual. And there we're going to be more opinionated on what type of architecture you publish to, how we manage access to it, what do we do for data rights. We're going to, if people are abusing it, or we'll try to detect groups. Abusing is the wrong word. They don't think they intentionally abuse it, but we always run into people that, write some code, deploy it, and don't realize that they're doing damage to the organizational infrastructure.
Sure.
So you do have so we have a organizationally, we actually have a group that kind of owns that function of that that we're calling it a platform. We're calling it a platform, and that's mimicked in companies like Amazon and Netflix and others. They really have redefined the use of the term platform in the world of IT to mean to mean a system upon which you build more systems the same way, things you can replicate.
Right.
Yeah. So we're trying to do that. It takes time. We started down this path a couple years ago, and maybe 3 years ago, and I think got a lot of deer in the headlights looks from architects and management teams and such. Like, why would we do that? And you do it a piece at a time. If you got 20, you start with the first one, and you don't get a lot of value from the first one, but it's the network effect. The more groups that subscribe to this, the more data becomes available in a common format, the less of the spider web you tend to rely on. So
starts to compound.
In 2 more years, we'll have be reaping a lot of benefits from this type of thinking.
Can you, and I should know this, but with Kafka, can you create kind of global namespaces? Or can the enterprise, it can track, it can create like catalogs and all that sort of goodness, or is that?
Some of it does itself, and some of it we've had to roll our own. And like cataloging and namespacing and things we can do. We to make it self-service, we automate some things. I honestly don't know out of the box what it does. I think you can do Kafka open source like we do, or you can go to Joe's Kafka vendor or to your favorite VAR, and they'll integrate it for you, and probably have some secret sauce that they'll roll into it. Nothing wrong with that if you don't want to hire a big Kafka support staff.
Yeah, absolutely. So, Tom, operationally, if we just look at actually, scaling it and operating it, it seems like it's one of those things. My intuition is that it must work really well, because literally all the large enterprises. But maybe I'm wrong. But it just does it?
All these things they always come with challenges, right? Sure. Everybody loves Kafka till one of your brokers crashes at 3 a.m. and the entire platform can't replicate fast enough, or recover from a broker being gone.
Right. Theoretically.
Yeah. Right. Theoretically, that's never happened.
No, never.
No.
Never.
But I mean, it's just like any other system, right? It still has guarantees on storage. It still has to replicate and duplicate data. All of that has to happen over a network connection and some sort of fast network topology for I/O. You have the potential to store massive amounts of information, right? There was a point during our sort of peak loading window where we were, floating 8 to 9 petabytes of data in just one pair of Kafka clusters. And so, there's a lot of different elements to it, right? You can push data in quickly. How long do you let it sit there? When does it expire? Do you want to keep things around after they've been read one time? or can you just expire it? I mean, so there's a lot of in-flight variables that you have to account for in the design. Fast disk IO and fast networking between brokers and if you're still using Zookeeper, low latency connections through Zookeeper, appropriate Java JVM memory tunings, and there are some things at scale that creep up that wouldn't ever happen if you're just running a small 5 nodes on little machines with couple gigs a heap, right? So and those things are really fundamental to how it's working under the covers, but you have to dig deep and get to that level of knowledge of the product in order to understand where you're starting to push limits, right? Just like any environment, you have to understand where your stressors and your limits are, and what levers control those. So it's just it's yet another data processing, data IO mover that still operates against the fundamentals of Linux and hardware and file systems and network and the physics that are inherent in the
storage things.
Right.
Anytime you deal with storage, I would always recommend people start the conversation with lifetime or data lifecycle, and they never do. It's always like, well, we'll figure that out. First year we got enough to store a year's worth.
I need to keep it forever. Set it for
we'll just
10
keep
years.
it for the first year, and then we'll talk about it then. And then a year goes by, and they're like, "Oh, we don't really know. Let's go another year." And pretty soon you're 10 years into it, and you say, "Well, 10 years sounds about right. Great. Did anybody write the processes down for how to delete data? No. Oh, well, we need another 5 years to figure out how to do that." So you end up, with these systems, you need to start with life cycle, because Kafka says you can put tags on it to say this data expires in 6 months or a year or whatever, and it'll handle it. But if you don't set those tags properly, you'll end up someday having an operational issue.
Can you guys just set them at a default it's of 1 year and that's it? Can you get the organization to deal with the fact that they've got to come up with they've got to move it or deal with it in a year?
I mean, you could, from like an administrative perspective, just enforce a rule through your config management or whatever your policy management tool is, and never allow a topic to be created with an expiration beyond a certain time period, right? You could even get very specific about it depending on how good your automation is, and have it become programmatic where as you're going through the process, you can identify data types. You could set retention requirements around data types, and then anytime a topic is created for a specific data type, it will get a specific retention period, or get other specific configurations that are limited to just that topic. So kind of to Randy's earlier point about being able to namespace things out and isolate, separate, it's mostly at a topic level, and there's support for RBAC and all that kind of stuff, so you can segregate who and what can do what things in those topics with messages. But largely it's able to be manipulated through configuration. So it's up to how robust your configuration management is. If people can go create whatever topic they want with no limits and no retention,
infinite retention.
Right. I mean, I've seen topics that have 10-year retentions for data that gets read one time, 1 minute after it's put into the topic, for no reason, to Randy's point about not understanding your data retention needs. And then you get clusters that just get huge and cost you a lot of money, right? You got to pay for all that storage. Whether it's internal money that I give from my team to another team, or if I'm doing this in a cloud environment, it's going out the door, right?
So what about security? So you've got this. Is that relatively straightforward? Isolating, people from streams that have maybe sensitive data, or do people put sensitive data into Kafka-like infrastructures? Is it considered secure?
It's like anything else. The technology is there to make it secure, but the trick is always figuring out who should have access to what. So if you have good policies in place that define your security with role-based access control or group level assignments, it's going to work. There's a lot of capability there. If you think a base fundamental tool or piece of infrastructure like Kafka is going to come in and solve your cruddy organizational view of security, no.
You got a bigger problem.
It'll accept ACLs, I guess, that other systems can help you define or at least describe. something like Active Directory or an LDAP, or pick your poison.
Yeah.
But I mean, in itself, that's not its role.
Yeah.
Right.
Interesting. Yeah. Do you guys work in an industry where personal data can be pretty sensitive? Can Kafka? I would assume that you can transfer that kind of data through it, or is that something that you? Okay.
Yeah. All the in-flight traffic is all, at least in our clusters. I can't speak for every cluster out there, obviously, because if you build your own, you can have different requirements. But all of ours, between all internal components, whether it's brokers between each other, Zookeeper, or clients, it's all mutual TLS. So we control the issuing and signing of the client cert before even any access could be established, and then it's based on ACLs. And
I see.
Yeah. And in this day and age, implementing a system like that doesn't have mutual TLS is irresponsible. There's just no reason. People could have argued 10 years ago, well, that uses a lot of CPU horsepower, and to use
it's
that
hard.
Or it's hard. Yeah.
Yeah. It's not hard anymore.
It's not hard, and the acceleration is built into every piece of hardware that you own, and from your cell phone to your Xeon processor.
Sure.
So,
Yep.
Absolutely. Very cool. So maybe let's wrap up this topic. So do you have anything you'd share with the audience in terms of hey, they're behind you a bit. They haven't deployed Kafka yet. Both from any suggestions or thoughts to share with people, how to build the infrastructure, how to organizationally deal with it?
Bigger is not better.
Yeah, I was going to say start small.
Yeah. Start small, plan to scale out.
Okay.
Yeah, I think that covers a lot of it. And the other is
both organizationally and physically, and just from technical and organizationally.
Organizationally is really hard. It depends on your, what type of roots you have, but definitely it'd be great if you have the kind of organization that lets people aggregate and define things at a corporate level or at a centralized level to attack it as a new platform offering and say, let's do this right from, the first time. But that's rarely how things get innovated, so it's probably going to be some rogue development team that shoves it into the corner of their infrastructure. So if you see it, don't ridicule it, find out how it works, and maybe adopt it as a corporate or a company standard. Organizations.
Yeah. And like any good open source project, right? If you really want to get into the depths of it, go find the GitHub repos and comment threads and forums and chat rooms. And the developers are out there and they're active and they talk a lot, right? And they're so if you know how to speak their language, that's the easiest way to go get yourself up to speed outside of getting your certification or taking a course. That whole idea of open source knowledge sharing is still out there, especially in these bigger projects.
Very good. Yeah,
I think that's where you get to the depths of what's really going on.
If you really want, get a vendor. Don't be ashamed to ask for help.
Right. Not everybody needs to be an expert on how to run large scale Kafka servers.
If you're a 10-person IT shop, you don't have the ability to spend a lot of time reading the manuals. Unless you do it on your own time. But if we're a 10,000 person IT shop, so we can carve out.
It's very hard to learn to fly that plane while it's in the air. The consequences are significant if you make a mistake. So
well, and to be honest, that's kind of the reason that I started with you two in particular for this broadcast. So when I talk about enterprise innovation, the complexity and difficulty goes up non-linearly with the size of especially the organization. And so that's where I think things get interesting. But I can also say my employer, Oracle, is just, we're pretty much balls to the wall with all of the products supporting Kafka every which way, every way they can. From the database to Golden Gate, which is a fairly kind of a multilingual data transfer engine. So it's and I think it's all good. Cool. So if you've joined us kind of in the middle of things, just again, I'm Matthew O'Keefe, and I work at Oracle as a corporate technologist. My two guests are Randy Olinger and Tom Hudak, who are with a very large enterprise firm that will remain unnamed. But I can assure you they do a lot of very interesting and cool work. And so we're going to move to our next topic, which is, unless you guys have anything else you want to mention on Kafka before we move to our next Next topic.
I'm done.
All right, very good. So there's been, obviously it's never news that there's some new data breach or new kind of hack. It's essentially a war, an ongoing war that just never ends. It's the essentially equivalent of the 100 Years' War for IT. And obviously the stakes get higher every day with, for example, state actors, countries getting involved and putting resources against into attacks that often target corporate IT folks that are critical to infrastructure. So we saw several of them. Maybe we'll start with Colonial. So Colonial is a firm that manages logistics and coordinates trucking and pipelines and et cetera for oil and gas. It basically serves the Southeast and Eastern Seaboard. And they encountered a ransomware attack. So they were attacked by cyber criminals who basically took their data and then encrypted it and demanded payment so that for them to get their data back. And this really created a lot of problems. And it did really show that IT is, in this case, they didn't actually attack the physical infrastructure. It wasn't an attack on, for example, the actual operational pipelines or the actual logistics software. It was literally an attack on the business systems that effectively managed the orders and managed who would ship what, when, and where. And they literally couldn't run the physical infrastructure because they really didn't know what to do without that data. So we'll start with that. Could you guys, so I have to say, I worked in backup and data protection for quite a few years in my career. And it always shocked me how often it really does shock me how often these ransomware attacks come up, because it just shows that IT has still not really learned how to do data protection right. So is that too harsh a judgment on my side, or am I being too harsh?
Absolutely not. No. If you look out in the industry, and a lot of posting about this after it happened, when it was pretty much revealed, they ended up restoring from backup to get their data back. And you know what? Good for them. They actually had backups that were not corrupted.
Yeah.
Because half the time when this happens, people say, "Well, go to the backups," and they find out their backups have been wiped as well, because they were sitting on the same network, using the same infrastructure, and those all got encrypted as well. Lucky for them, they were able to restore from backup. I heard even after they paid some money, they still continued restoring from backup because it was faster to restore than to decrypt. Guess what? That's not news. We've always known that. If you have a good backup system, you can recover very, very, very quickly. So good for them. But it's still a painful operation to go through as you're recovering, because you have to make sure that everything you create now does not have the same infection that your other stuff had. Otherwise, it just starts all over again.
Right.
So it's a difficult thing. I mean, we've worked with businesses adjacent to us that have had this kind of thing happen. There's one here in town that I won't mention. They're not part of our organization. I heard they've been hit 3 different times from ransomware.
Wow.
And it gets into one of their shared file systems, like a NetApp device. Not that NetApp's the problem, but a shared file resource, and just starts to go wild. And all you need is one workstation that's on the LAN, and it can encrypt a lot of data really fast.
Yeah. How are they? I'm not sure. I know you guys aren't like strictly security experts, but is there a primary vector of attack for ransomware, or is it just all over the board?
Send you an email that has an attachment that says, "Please open me."
Okay.
Yeah. That's still number one.
You still see things like people exploiting 0 days, right? And SolarWinds is an excellent example of maybe one of the most epic backdoors I think I've heard of, right? Just having their code changed in a tool that they're loading from an external, I think it was an external source maybe, and somehow the code got approved and merged in and was there and allowed access. And for a company like SolarWinds, I mean, what a devastating. I mean, it's ironic. If it wasn't, if it
shakes your faith, doesn't it?
Yeah. If it wasn't so incredible, like dangerous, it's comically ironic.
And you want to take your hats off to the hackers in a way, because it's like, well done.
Absolutely.
Well
There's
played.
a lot of people think it was a state actor, so there was some talk. It might have been Russians.
Make a lot of sense.
Yeah.
I can't help but think of the parallels to the U of M students that recently tried to submit bad code into the Linux kernel.
Yeah.
As an experiment, right? Like, I get what they were trying to do, but there's a specific way and a specific code of conduct for dealing with the Linux kernel. So
Right.
if you wanted to do that, there's a way to approach that situation and try it,
Yeah.
right? But they didn't do it the right way. They did it in a way that broke the trust of a network that is entirely built on trust, right? So
Right.
once you violate that trust, you're out.
Yep.
SolarWinds as a security company having that happen should give anybody who uses SolarWinds, pause to think about, okay, these guys are marketing themselves as the best out there for this kind of stuff.
Any proprietary security company that you trust, you shouldn't trust. Basically, they're only as good as their firewall admin or whoever, whatever is monitoring their infrastructure. So I read it. Just happened to read an article this morning. I think it just came out today, 10 years after the RSA hack. So I don't know if you guys remember this, but about 10 years ago, the RSA tokens, which we all used to carry to get onto different types of VPNs and such, their company got hacked, and it turned out to be state actors. The Chinese government went in and recovered all of the seed keys from every single RSA token that had ever been issued or minted, and essentially devastated their security. And now I do remember, because our company had to come out and mitigate. We changed some of our lengths and strengths of the passcodes that you remember in your head and such. But it was devastating to the RSA token. And if I look around, guess what came out of that? Now you have hardware keys and smart cards or the FIDO specification.
You air gap with two-factor, things like that, right?
And much more. And there's authenticators on your smartphone, apps like that, and text back systems. So RSA kind of had that market locked up. They had this breach, and they lost it. Now I'm not saying they're still a big player. They're probably still the biggest player, but they were the only player for a long time in that kind of two-factor authentication. The other thing is it made me realize that hardware tokens will always fail now, because one of the things they couldn't do after that was manufacture enough tokens to replace them for all their customers. It would have taken years.
Right.
But a soft token on my phone, I can erase the app,
immediately
download a new app, and be off and running. So even if it's not quite as secure as a hardware token, the fact that you can recover from a breach faster is probably a better move.
And these things are not new. I mean, maybe the specific vector of getting bad code into a repo, into a Git repo, through a commit, through writing very obscure abstract code that's hard to identify a specific purpose to it, right? But together with other bits of code, it comes together to make a thing. It's not new. It's just that approach through Git and through public repositories and public code commits and contribution is a new method I haven't really seen employed effectively before. But go back to even like the early the elliptical curve salting stuff that the NSA was doing, right, where they were planting people in the board who would propose pre-salted known salts to the elliptical curve committee, and then they would approve them, and now the people who had the knowledge of that salt could decrypt all of that stuff, and that was the NSA, right? And they ruined the trust of all crypto, and all those curves got rewritten and redone without those people present or part of the process. And but the people, if there's a big enough reward, somebody will take the risk to go out and try it, right? And boy, being able to break all of the world's crypto, that's a pretty big reward. Right? Or get all of an entire company's logins and all of their network topology and architectural information and their entire network layout, all of the servers that they have. That's huge. Those are huge wins.
The other one that I remember happening, and it was another ransomware, and it was just a few years ago, was the NotPetya. So NotPetya started spreading all over the world, and it was a bad thing, and it hit a bunch of hospitals, I remember, in the UK and more in Europe than in the US for whatever. I think just because of time zones, we were able to catch it sooner. But the company that I read about, and I posted a link to the article that we'll have in the show notes, hopefully, but they got shut down. It was the largest shipping company in the world, Maersk International, and they run container ships and ports, and they were shut down for several days because of this. So it reminds me of the Colonial pipeline hack. But the thing that's so interesting about that is This thing ran through their data centers, not one, but all of their data centers, and essentially shut them down in about 45 minutes.
Wow.
I haven't read the article again. It's been a few years, but what it ended up doing, as soon as it hit one Active Directory controller, that thing replicated the garbage to every other Active Directory controller, which essentially made it impossible for anybody else to log into the system.
Right.
So if you think about that, if there's one asset you need to protect, it's going to be your centralized, LDAP or Active Directory.
Yeah.
And the only way they were able to recover this was fascinating, is that they happened to have one AD controller that had a power outage and was down.
Okay.
And the people were working on it. It was like in Kenya or somewhere. And they
Really?
were working on it, trying to bring it back up. Yeah. And they called them and got them within minutes to say, don't turn the power on.
Okay.
So they didn't. And they flew people out there to get the hard drives. They split the mirror, tried to bring one of the hard drives back to Europe to work on it. I think it was Great Britain. And the funny thing is, the authorities were like, what's in the briefcase? A very important hard drive. We have to take this data. And they're like, you're not taking that data out of our country. So they almost were able to get their own AD out of the country as fast as they did. But they were able to bring back the mirror from that, recover the entire AD in a matter of a couple of days and be able, but they didn't have backups of their Active Directory, which most people don't. They figure, I'll replicate it 80 times and I'll be fine, right? Yeah.
Right. But if they could break the replication, there you go. Yeah. Was NotPetya, was that a state actor, or did they ever figure out what that was?
It was not a state actor, I don't think. I think it was one that the people that wrote it never thought it would go as wild as it did. And some random dude discovered, in Great Britain also discovered that there was a domain name that the code was referencing. And so he went out and just created that domain name, and whoosh, the whole thing shut down. So there's a pretty fascinating virus.
Yeah. Yeah. There's kind of a bigger issue here. So it's interesting when I was, reading some security architect specialist guy, and his analogy was to talk about the days of piracy back in the, say 1500s, 1600s. So if you think about it, what was happening then? Well, basically the world was essentially very large and sparsely populated relative to the kind of the logistics of the day, the ships that could move around. So if you were a pirate, you could basically kind of pick a vulnerable ship to attack, or maybe isolated fort, because bottom line is it's just this sort of very large, sparsely populated world. And sort of digitally, that's kind of where we sit right now, which is you have corporations like the ones you guys work for, my company, and just thousands and thousands of these companies scattered everywhere in this very large digital universe. And the state actors are like the state official pirates that the British and the Spanish and the French used to have. I forget the name.
The East India Company and the privateers.
Yeah, privateers. Yeah, so they're basically private military. So you really have that similar kind of situation. And what's odd to me is, why does the government, essentially the U.S. government, doesn't seem to really have a strategy for helping companies like Colonial and just these companies that are relatively vulnerable. I mean, I think in industries like finance, that seems to be pretty good. There's so much controls and regulation that seems to hold, basically things, it seems to hold things off. But you see just a lot of isolated, fairly vulnerable. What was the credit scoring company that got hammered?
Equifax.
Yeah, Equifax. There you go. So it seems like we essentially spread the risk among a bunch of companies, but when you have these state actors that can individually target one of them, it's like a state-funded privateer going after a vulnerable, whatever, Spanish galleon out in the middle of the Gulf of Mexico. There's no British Navy. It's 1575. There's the British Navy isn't big enough to go, to cover it.
Even America, with all of our riches, we're still, 57 states? Is that what we're up to now?
That's right.
I'm sorry, is it only 50? Okay. In other words, we have 50 states, and each one of those is a gold mine in its own way. If you could, so there's billions of dollars at stake, and the states aren't that good. I've worked with our state government, and they're not bad, but they don't pay enough to get the
just look at the Minnesota DPS problems they've had the last couple of years trying to get their all the licensing, and that's they're hiring CTOs, but they're paying half of what you would make as just like a normal software engineer for Google, right? So no wonder you're not getting high caliber, super power, high powered people to run these
I
teams
was
and
told when they worked
organizations.
with them, remember, no one in this environment can make more money than the government by state law, or than the governor by state law.
Right.
And the governor makes $130,000 a year or something. It was something like that. It was,
Right. Yeah.
and hey, I'm sorry if you just heard that and you're not making $130,000 a year, but there are a lot of people that make a lot more of that and expect a lot more of that if they're going to work full time and
Right.
be a top-notch contributor in an IT organization.
Yeah.
Oh, yeah.
So,
Yep. Absolutely. Very good. Okay. Any final thoughts on that issue? I mean, obviously, we're gonna, it's the 100 years war, and we're like in about year 30, 35, maybe.
Don't trust anybody and stop putting all your eggs in one basket.
Yeah. I mean,
we should probably do an episode on crypto.
Yeah.
Cryptocurrencies. That'd be
Yeah,
fascinating.
we could do that. Yeah. I mean, what about, okay, so one last little, so, again, my company tends to push defense in depth. So people, obviously there's network perimeter security, but we try to put a lot of, crypto into, there's encryption at the database, for example. There's other things you can do, database firewalls, audits, control of who can access, et cetera, et cetera. So are you seeing more defense in depth? Is that something that, and redundancy? Because it just seems from a military standpoint, it's like having a reserve. Typically an army is, it needs some kind of reserve to react to problems.
I think I'm seeing less.
Are you?
I literally don't feel like we have the emphasis on it we had 10 years ago.
Seriously? Okay.
Yeah.
Tom, what's your viewpoint?
Yeah, I mean, I look at things like, Jenkins. Jenkins is like, for a lot of organizations, one of the biggest security risks that there is, because so many credentials get stored insecurely and run by Jenkins with third-party plugins that nobody's ever looked at what they do, right? I mean,
Okay.
how easy, if you look at SolarWinds as the example, right? How much effort went into changing code in SolarWinds to give access, right? It would be trivial by comparison to do it in a third-party plugin that Jenkins uses that could exfiltrate, every SSH key you stored and every mutual TLS certificate and, user credential that's stored in plain text throughout all of Jenkins. And now so these are, I'd say, no, we're not doing as diligent a job as we used to. I think there's still a very healthy security practice and security industry out there.
Yeah.
But I think in general, the sort of lay network and systems engineer out there is not nearly as involved with the security of the platforms that they operate as they used to be. And things have shifted into more like a centralized silo of security.
And that centralized silo has been empowered, but in a way, I don't know. Their stated goal is keep us off the front page of the Wall Street Journal for most big organizations.
Yeah.
I think the best thing to ever happen to information security officers, chief security officers, was the Target hack. Because up until then, there'd been lots of companies hacked, but their stock prices didn't really seem to suffer all that much. And everybody kind of came out of it and they apologized and moved on. And maybe they had to buy you some credit scoring or whatever. But in general, you moved on and everyone said they were sorry and moved on. The Target hack comes along and a few months later, the CIO is fired, and every CIO went, holy shit, that could be me. If I'm not mistaken, it wasn't too long till the CEO was fired over that. And all of a sudden it's like, wow, now that's my job that's at stake. And every CEO in America called their CIO and said, what the hell?
Yeah.
The CIO said, well, that could probably happen to us. We have vendors and we have insecure systems, and to be in disclosure, I'm not that we do, we're perfect in our company, but it could certainly be. That's what I tended to see across the industry at that is ISOs became much more empowered after that, but it was only driven out of fear, right? So a lot of panic buying, a lot of draconian actions taken, not necessarily a lot of thinking about, are my backups current? How quickly could I restore my data center? Do I have differentiation between archival systems and online systems so I know what to restore first? Do I have policies in place so that my business has signed off on that when I have a disaster, here's who gets processed in what order? Because If you're a large company with 800 different business units and something bad happens and every one of them wants to be at the front of the line, you're going to just have a bad day.
Yeah.
I mean, it's funny. The backup and restore thing is I'd say more important now than it's ever been, because you start talking about the amount of data people have and the amount that you would have to restore if there were some sort of loss or encryption, right? And it becomes that much more important. But 10 years ago, every conversation that I was involved in architectural context, one of the critical criteria that you had to answer was your RTO and RPO for your backup, right? And the business had to sit there and go, it needs to be a day, right? Or it needs to be 8 hours, and they had to figure it out. And then they designed the backup system around that requirement. I haven't heard anybody bring up RTO and RPO for the backup of data in an architectural context in a long time. So there are fundamentals, I think, that are either being lost or missed or forgotten or have siloed up into a different organization, and because of that, they lack the understanding needed to really craft those policies well.
Think about Colonial, right, Tom? It just gets to the point about RTO, right? What's their recovery time objective?
Mm-hmm.
Obviously, they essentially it cost them, hundreds of millions of dollars.
On probably a $5 million bet, right? That we won't need it, so don't worry about it.
Yeah,
right. We don't want to spend the $5 million for that extra tape library.
Backup is always is underfunded. This is industry wide, underfunded and underskilled. It's usually not.
It's not sexy.
It's not sexy. It's not where someone gets out of college, make them the backup admin for a year.
Yeah.
And honestly, everyone should. You'll have a lot more respect for them if you do, because it's hard. The other thing I was going to say is the tools haven't seemed to have gotten all that much better in the last 10 years. I mean, there's been a lot of new products out there rolled out for pretty much just virtual space backup. Essentially VMware special sauce backup,
right.
And that's pretty cool. But most of those products, I don't think scale. If you've got 40,000 VMs on 68 clusters in 7 data centers, you're going to have at least 68 instances of that backup system to manage. And every one of them, you have to figure out capacity. Every one of them has to have a budget. Every one of them has to have people assigned to it. Nobody does that. They just turn them on and cross their fingers,
Yeah.
So the tools just suck.
Yeah.
They haven't cut pace, right? I think that the cheapness of storage and the speed at which it's grown versus the speed at which we've been able to consume it, not keeping up with that, has led to a lot of duplication systems. Yeah. Which only really account for, one sliver of one side of the whole backup, the two sides of the backup coin, right? Which is I can lose that physical thing and I've got a copy of it over here. But what happens if it gets deleted or encrypted, right? You're not accounting for the logical destruction of data.
And recover versus restore.
Right.
Recover is, oh shit, I deleted my database, so go get it back. And restore is, oh crap, my servers are gone. Let's start from scratch.
Mm-hmm.
Yeah, and Oracle actually has a product, a backup appliance, zero data loss recovery backup appliance. And actually, I was kind of blown away when I first joined Oracle as to it's basically can handle all these edge cases, RPOs of essentially zero. So
for the Oracle database and other Oracle products probably.
Yeah.
And then it's like you can buy one of those for IBM for your IBM products. You can buy one of those from Dell for your Dell products. You can buy one of those from HP for HP products, and I could go on. I mean, the problem is
Oracle's different, Randy. But I mean, seriously, we're not, the bottom line is people, we have crown jewels of data. But literally, that's exactly why we don't, I'm not going to say it's let's just say it didn't reach sort of data domain levels of popularity for that very reason. And yet I have to, and I've told folks at Oracle, that's exactly why, people want sort of they're concerned about having specialized products, but it's kind of the same argument we get into people with, like, should you put everything on VMware versus say a specialized appliance for running Oracle? And there's lots of trade-offs, but yeah.
Mainframe's an interesting world. It's still pretty big. I'm sure it's getting smaller every year, and nobody knows the numbers because they're not released. But mainframe tape, we got rid of mainframe tape years ago and went with a disk-based tape emulation solution and all that. I kind of wonder what would do we have a thorough understanding of the vulnerability of that? Because I think it's just NFS running behind some Linux boxes, and if they're on the network, boom,
Yeah.
they're vulnerable like anything else.
Yeah.
Right.
Absolutely. Cool. All right, so we've got about 9 minutes. Let's talk. You guys, we were all talking in chat a little bit before the show, and Linux infrastructure came up. We were talking Linux file systems a little bit. So Linux core, literally core to everything we've been doing. I've been talking about because they're so ubiquitous, obviously in clouds as well as the enterprise. And Tom and I first met when our Linux storage management software company was actually building the Linux Logical Volume Manager. So we had the original LVM guy, Heinz Malshagen, and then built a team that worked with the rest of the obviously Linux kernel hacker team, and have really built LVM into a really popular tool. So there's a lot of different file systems in Linux. Btrfs has been out there for, I don't know, a decade maybe. And it's had a lot of promise, especially on the snapshot side, but it's a hard problem. It's a hard, difficult technical problem. So I don't know. Any thoughts on what you're seeing lately on Linux and the storage side?
Boy, I pay less and less attention to it. I try moving more. I mean, XFS has become kind of ubiquitous for like clustered, non-redundant, no RAID or whatever.
Yeah.
Software RAID's still a thing, but I feel like, hardware RAID has just gotten so good that there's not really much point in doing the software side anymore. But yeah, I mean,
I don't know. I think, the last time I looked at this heavily, about 5 years ago, we were looking at open source storage opportunities to try and disrupt our kind of vendor managed storage that we had in the data center. And then we weren't looking to throw everyone out. I mean, I totally respect the storage platforms because, you buy yourself the top tier EMC, Hitachi, Dell, Compellent, one of those arrays, you turn it on and you run it, and 10 years later you turn it off. There's no outage. Typically, there's no outage. That is not an easy system to make.
Yeah.
And what's underneath every one of those systems is usually some sort of a file system, either their own or built on top of a Linux box. Now, a lot of other companies like Pure or Extreme.io or Oracle have their kind of flash storage based appliances, which are, they're awesome too. And the key problems still haven't gone away though. How do you build something that's scalable, that's consistent, that's reliable, and that can service essentially the whole planet at the same time? They're still battling network latency and things like that. I don't know. The Linux storage system is just one part of that whole stack. I have not used Btrfs, and quite honestly, I have no plans on it unless I absolutely have to. I mean, it just, every time I've been reading about it, like you say, for 10 years, and I think in Fedora it might be the new default if you build a new system, but I'm like,
yeah, I think so.
I take a chance. My file system isn't my problem today. So ext Fedora,
right.
XFS, they're good enough. I don't really care. If I was building a storage appliance, if I was building out a massive Lustre system like we were talking about, or if I was doing HPC, your next podcast might have a complete different view on this if it's because it's HPC focused. Little teaser there for the viewers.
Yeah.
But for us in the enterprise, it's not. Don't care. Plus, I'm more cloud focused now, so let Amazon, let Microsoft, let Google deal with it.
Sure.
It used to be storage used to be a scarcity, right?
Right.
And so the speed of it was difficult to obtain, and large size was expensive, right? And they were both expensive, but it still is, but not to the degree that it was, like in the late 90s when we were doing LVM, right? And GFS, right? Because the biggest disk you could get, I think at that time, was 18 gigs or something like that. Yeah. And now I can get 10 terabyte drives that have NVMe in front of them, and I can get 100 of those for the same price as I could get 1,000 18s back in the day. Right? And but I can hold 1 million times more data, right? So I don't need to eke just a little bit more storage by properly setting the block size of my file system, block layout, or try and get a little bit more performance by using this type of read pattern versus that type of read pattern, because I don't need that anymore. I'm not operating on those margins any longer, right?
Sure.
called clustering, right? We, how much time was spent trying to get like the network block devices working through POSIX locking it.
Yeah.
And now nobody even thinks about that stuff, right? It's just people take for granted cluster and Ceph and simplified non-POSIX file systems that only support 4 things: read, write, update, and delete, right?
Yep.
Yeah. Well, Object Store has made a big difference. People have, I think part of it is they just learned to accept a lower performing file system and wrote software up higher in the stack to compensate for it, or just, quite honestly, a lot of people also realize all these edge cases everyone got wrapped around the axle on are either so rare we don't care, because I don't know the whole answer, but it hasn't come up, and maybe it's partly that I've moved up the stack. I don't deal in the data center anymore. I don't deal in the server creation or the decisions around performance at the bit and byte level.
SSD really kind of changed the game, right?
Yeah, it did. It took away all the lower hanging problems, everything
that's
else.
a good point.
It got cheap enough you could just throw a little hardware at it, and that lasts for a while.
That's a good point. But
if you're Shutterfly and you're storing gigawatts of pictures every single day, they have those real problems, because they're trying to they're still using spinning Rust disk because that's where the density is. But Object Store makes a huge difference, and cloud actually abstracts a lot. I mean, my God, some of these cloud providers, not the big ones, but there's the more niche storage providers like Backblaze. They're half a penny a gig per month.
Yeah,
that is like free. That's like drinking water.
Yeah, it's super cheap.
This is my 2 terabyte drive with all my media, my video and photographs. So it's totally backing up to Backblaze. It takes like a month to get it up there. It's $60 a year.
Mine syncs every night to Backblaze.
This is the first one. So those guys are awesome. Remember at the massive storage conference? They have just, and then the fact they open source their hardware design and
they report every year on different brands of hard drives and the failure rates. I just have a lot of respect for that company, and they've managed to keep the price down. They're just
I need to, you know what? We need to get them on the show.
Cool. We should get them on the show. So I used to work for Code 42, right? And
another great one.
You did a turn there, huh?
We were building Crash Plan at the time that the Backblaze guys were doing like the vertical slot chassis to maximize drive density in their servers, and we took quite a few cues from them. But that would be really fun to talk with those guys.
And they do talk publicly, so they'll dig into the details. That's one of the best things about them. So I'll talk to Gleb Budman, the CEO, is a good friend. So I'll let me reach out to him. Cool. Well,
tell them I just signed up for their B2 service, and I keep hitting my daily upload limit. I can't.
You must not be paying enough.
I can change it. I can change my upload limit, but I haven't dug into all the settings yet.
Yeah. So anyway, it's been great to have you guys on you two very smart guys, modern times. Here's 2 smart guys from a few years back. Do you guys recognize who that is? Oppenheimer. That's right.
Oppenheimer. And
who's the other one?
I don't remember the other guy.
Von Neumann.
Oh yeah.
So they're in front of the Mark IV computer at Los Alamos.
Cool.
So this is like around. It was either maybe slightly after the war, or maybe during the time of they were building the weapon. But anyway, as many people know, the Los Alamos was kind of the hub for the building the first atomic bomb, and they had these just absolutely stunningly brilliant people, the best physicists, the best mathematicians from around the world there. So next week. On Wednesday, we will have our next guest, which is Gary Grider, who's the high performance computing division leader at Los Alamos. And he's going to talk about how the nation's leading nuclear weapons lab innovates with HPC. So again, the theme here on our on this enterprise innovation broadcast is basically how do you basically innovate in these big, sort of at this big scale organizationally, hard problems, et cetera. So that'll be 4 to 5 p.m. on May 26th. I'll leave up. Maybe the best thing is follow me on LinkedIn. So look for me, Matthew T. O'Keefe on LinkedIn. I'm also on Twitter. And then this YouTube channel, we're broadcasting to a YouTube channel under my name as well. Maybe we'll create a separate channel for this specifically, but currently it's under my name. But so that's where you go. And so with that, I want to thank my guests, Tom Hudak and Randy Olinger. I think it was fun and useful, as always, and I really appreciate you taking the time on a Friday. And I'm sure I'll have you back at some point here in the pretty near future. So thank you again. Any
Always a pleasure,
Great
Matt.
fun. Always happy to.
Yep. Great. All right. Thank you
Right
very much.
Thanks, guys.
Take care. Yep. Thanks. All right. So.